Within the fields that encompass rare earths, strategic materials, and critical elements, there seems to be a great deal of hype and conflicting information. Opinions on this subject appear to be fragmented and inconsistent, and there may be a lack of fundamental understanding of what these elements are, and how to classify them. There may exist conflicting strategic approaches, social attitudes and competitive positioning in the political, academic and scientific communities and within industrial circles. Rare earth elements are associated with, and are generally considered to be part of, or related to, Group 3 of the periodic table. Group 3, which is sometimes referred to as the scandium family, includes scandium, yttrium and a collection of lanthanoids and actinoids. The grouping of lanthanoids or lanthanides are a series of 15 metallic elements, with atomic numbers 57, which is lanthanum, through to 71, which is lutetium, and is included in a larger group that is referred to as rare earth elements, which is commonly denoted with the acronym REE. Rare earth elements are a group of 17 elements, including the 15 elements of the lanthanide series on the periodic table of elements, together with the transition metals scandium and yttrium. The latter two elements exhibit similar properties to the lanthanides, and are typically found in the same natural deposits of ores. REEs are key components in many electronic devices that we use in our daily lives, as well as in a variety of industrial applications. The actinide group, or actinoid series, comprises of 15 metallic chemical elements, with atomic numbers from 89, which is actinium, through to 103, which is lawrencium. This group contains radioactive elements such as uranium and thorium. With a current perception of the need to increase electricity generation, there is a growing interest in nuclear power and potential sources of nuclear fuels. Naturally dispersed scandium group elements are typically spread out in low concentrations throughout the Earth's crust, and are not commonly found in concentrations great enough to be attractive, or economically viable, for commercial mining purposes. Scandium group materials are more commonly accumulated as byproducts from the processing or refining of other materials. Recently, some efforts have also been focused on the potential opportunities presented by the extraction of scandium group elements from seawater mining, and from the treatment of brine concentrates and also from the recovery of e-scrap residues. Critical materials contained in modern waste streams such as e-waste and microelectronics, and end-of-life battery materials, present an attractive potential as a source of recoverable scrap. One unique area that requires more attention is the recovery of permanent magnet materials. This may be a specialty area of activity that might yield a considerable consolidation of a quantity of magnets for recycling. One type of behavior that needs to be curtailed is the treasure hunting syndrome, where in a blind lust to extract the treasure, it lures you to expend hundreds of times more in cost than any return from the total value contained from within the minute quantity of material that might be recovered. More commonly, waste generators have adopted the practice of paying a fee for the treatment of their waste materials, to ensure the avoidance of future post-disposal liability, and to mitigate negative environmental impact. Recovering strategic materials and critical elements, even if there is no net economic gain, reinforces the conservation of finite resources. We may be able to justify the cost of recovery, if those costs can be brought into an acceptable range, by operating a default multi-stage, multi-material residual management approach of consolidating byproduct residues, to recover the strategic values from these materials. The Recovery 2.0 project may result in gaining some level of understanding and expertise in the realm of residual waste materials management, and the resource recovery of critical materials and strategic elements. Recovery 2.0 is a project developed by Waste.net, in an effort to reinforce our belief that as rational human beings, we must accept the ultimate responsibility to leave future generations with a safe and sound environment, and a world that has not been depleted of its resources. Please feel free to visit us at www.waste.net.